Hello everyone, I am Rupishri from Sri Venkateshwara College of Engineering. Today I'm going to talk about bubble sort in this video. Today's agenda, first we'll talk about what is brute force approach, then we'll go to introduction of bubble sort, algorithm, pseudocode, example, advantages and disadvantages. What is brute force approach? Does anybody know? Let's talk about it. A brute force approach is a straightforward problem solving technique that involves systematically trying all possible solutions until the correct one is found. This method is simple to understand and implement as it does not require complex algorithms and data structures, making it a valuable tool for small input sizes, prototyping, and testing. Despite its simplicity, brute force is typically inefficient, especially for large problems, because it explores every possible candidate, which can lead to exponentially increasing time and resource consumption. Example for this brute force approach, password cracking, trying all possible combination of characters until the correct password is found. Now let's talk about introduction to bubble sort. What is bubble sort? Bubble sort is a simple comparison based algorithm used to sort a list of elements in ascending or descending order. It operates by repeatedly stepping through the list, comparing adjacent pair of elements and swapping them if they are in the wrong order. This process is repeated until the list is sorted. Key characters, simple to understand and implement. Bubble sort is one of the most straightforward sorting algorithms, making it ideal teaching tool for introductory computer science courses. Comparison based. It compares adjacent elements, swaps them if they are out of order. In place sorting. It sorts the list without requiring additional storage space, making it space efficient with 0.01 space complexity. Now let's talk about algorithm. What is algorithm? There are a few steps to explain what is algorithm. To solve a particular problem, we use algorithm, the steps. Okay, here the first step is compare adjacent elements. Start at the beginning of the list or the array, compare each pair of adjacent elements. The second step is swap if necessary. If a pair of elements is out of order, the first element is greater than the second element, then swap them. The third step is repeat. Continue the entire process to the entire list or the array. Iterate over the list. Repeat steps 1 to 3 for the entire list as many times as necessary until no swaps are needed during the complete pass through the list. Next, we'll go to the pseudocode. Here, there is an array 0 to n. We will consider for I equals 0 to n, swap will be equated to false. And then we give another loop for j equals 1 to n minus 1. If statement is included here, if a of j is lesser than a of j minus 1, then the swap happens and swap will be equated to true. The if statement is ended, for loop ends here. If not swapped, break. We'll go to the next iteration. Here again, the if statement is end, and again, for loop is ended here. Okay, now we can see the steps. Initialize swapped to false. Second point, iterate over the list from the beginning to the end. Compare each pair of adjacent elements. If the elements are in the wrong order, swap them and set swap to true. Repeat the process until the complete pass through the list results in no swap. This brute force approach guarantees that the elements will be sorted by repeatedly pushing the largest unsorted element to its correct position with each pass through the list. Despite its inefficiency, bubble sort is often used in teaching basic sorting principles due to its simplicity. Now let's go for an example. We have an unsorted list. 5, 1, 4, 2, and 8 are the elements of this list. We have 5 elements, but the array starts with 0. We name 5 as A of 0, 1 as A of 1, 4 as A of 2, 2 as A of 3, and 8 as A of 4. So n equals 4. N minus 1 is equals to the number of passes. So we'll have 3 passes. The first pass, we compare 5 and 1. 5 is greater than 1, so we swap. In the second step, we compare 5 and 4. 4 is lesser than 5, so we swap. And then we compare 5 and 2. 2 is lesser than 5, so we swap. Then we compare 5 and 8. Here, there is no need of a swap because 5 is lesser than 8. This is the first pass. Now, let's go to the second pass. Second pass. Now we compare 1 and 4. There is no need of swap because the first number is smaller than the second number. We compare 4 and 2. We need a swap because 2 is greater than 2 is lesser than 4. And then we compare 4 and 5. There's no need of a swap. Then we compare 5 and 8. There is no need of a swap. Then we compare 1 and 2. There's no need of a swap because it's correct in the order. Then we compare 2 and 4. There's no need of a swap because it's correct. The numbers are lesser and greater than each other. 4 and 5, there's no need of a swap. 5 and 8, there's no need of a swap. So in this, there's no need of a swap. We find the sorted array as 1, 2, 4, 5, and 8. This is the third pass. As I told, n minus 1 is equals to the number of passes needed to solve an unsorted list based on how many, what is the size of the array. Array size was 4 and we have 3 passes. We have found the sorted array here or the sorted list. Okay, next we'll go to advantages. Simplicity and ease of implementation. Bubble sort is one of the simplest sorting algorithms to understand and implement. Its straightforward approach makes it excellent educational tool for teaching fundamental concepts of sorting algorithms and algorithm design. Small memory usage. Bubble sort is an in-place sorting algorithm, meaning it requires only a constant amount of additional memory space. Of 1, this can be beneficial when working with systems with limited memory resources. Best case efficiency. In its optimized form, bubble sort can be very efficient for nearly sorted data sets. When the list is already sorted or nearly sorted, bubble sort can run in O of n time by detecting that no swaps are needed during a pass. Stability. Bubble sort is stable sorting algorithm, meaning that it preserves the relative order of equal elements. This property is important in certain applications where maintaining the original order of similar elements is very, very necessary. Last, we have disadvantages. High number of comparisons and swaps. Bubble sort performs large number of comparisons and swaps, especially for the lists that are not nearly sorted. This results in high computational overhead and can significantly slow down the sorting process. Not suitable for large lists. Due to its inefficiency, bubble sort is not practical for sorting large lists. Time required to sort large data sets increases rapidly, making it unsuitable for the most real-world applications where performance is a concern. No advantage with random data. Unlike some other sorting algorithms that can adapt to certain pattern in the input data, Bubble sort does not gain any advantage with random data and will always perform poorly in worst case scenario. Redundant comparisons. In many cases, bubble sort performs redundant comparisons even after the list is sorted. Although optimized versions can detect if the list is sorted early, the basic version continues to compare elements unnecessarily. So this is all about bubble sort. We've seen introduction, we've seen the algorithm, we've seen pseudocode steps, how to understand the pseudocode. We've seen an example, we've seen advantages and disadvantages. Hope it's helpful. Thank you very much.